Hello students, myself Jyoti Kiran, Assistant Professor, Government Postgraduate College, Tiptur. Today I am going to explain elementary row and column operations. So what do you first we will see the definition of elementary transformation. Let us take the given matrix A be the given matrix. The following three steps of operations on a matrix A are called elementary transformations of a matrix. First, we have to interchange of any two rows or columns. The interchange of ith and jth rows is denoted by Rij. So here R capital R represented the row. The interchange of ith and jth columns is denoted by Cij. Capital C represents the column Ci to Cj. Then second rule is multiplication of each element of a row or a column by a non-zero scalar. K represents a scalar. The multiplication of ith row by a scalar K is denoted by Rik, that is Ri to Kri, or the multiplication of ith column by a scalar K is denoted by Cik, that is Ci to Kci. Next rule is addition of elements of a row or a column multiplied by the same scalar K to the corresponding elements of another row. The addition of the element of jth row multiplied by K to the corresponding elements of ith row is denoted by Ri to Ri plus Krj. Here addition and multiplication. Then the addition of the elements of jth column multiplied by K to the corresponding elements of ith column, it is denoted by Ci2. Ci operation is addition operation, then multiplication of scalar K Cj. If these operations are applied on rows only, then such an operation is called a row operation. And if they are applied on column only, then such an operation is called a column operation. Next we move on to inverse of a matrix by elementary transformation. So here we apply the elementary row and column transformation by taking a non-singular square matrix of order n, and we can find another matrix of the same order, say B. Here we are going to two non-singular square matrix such that the product of AB and BA is equal to I. Here I represents the identity matrix. Next we have to finding A inverse by using elementary transformation. Let A be a non-singular matrix of order n. To determine A inverse by using elementary operation, we have to write the matrix A is equal to In of A. Here I is the identity matrix and A is the given non-singular square matrix. For this A is equal to In, multiply A inverse on both sides and taking In is equal to BA. Then the above equation becomes A inverse is equal to, take In is equal to BA into A inverse. We know that A inverse is equal to I and BAI. Identity matrix multiplied to BA matrix, then it will become BA only. I is equal to BA. Therefore, AB is equal to BA is equal to I. Then B is the inverse of A. Then we get A inverse is equal to B. Thus, to find the inverse of A, as we apply the row operations on A to reduce it to normal form, we apply the corresponding row operations on the pre-multiplier in RHS also. Then we move on to the problems. In the first problem, find the inverse of a matrix. It is a square matrix of order 3 cross 3 by using elementary row operation. So we have to find out the inverse of the given square matrix. Then we have to take the given matrix as A. Let us take A is equal to In of A. Here n takes 3. It is 3 cross 3. So In of A. Then A is equal to In of In is nothing but I3 of A. Then here interchange R1 to R2. Here first is 0 is there to make it as unity. So interchange R1 to R3. So third row will comes first row. Then it will become this matrix. Then apply the for second row, apply this operation R2 dash is equal to R2 minus 2R1. Then it will becomes this matrix. Then again operate the row operations. R1 dash is equal to R1 minus 2R1. So then R3 dash is equal to R3 plus 4R2. We get this matrix. Then once again apply R1 dash is equal to 9R1 plus 4R3. Then R2 dash is 9R2 minus 2R3. We get this matrix. The principal diagonal elements must be unity. Once again apply these row operations. We get I3. I represents the identity matrix. We make all the elements below the principal diagonals and above the principal diagonal elements must be 0. Then we get the identity matrix. This is in the form of I3 is equal to B into A. Then inverse. This is the inverse of the matrix. Hence A inverse B is equal to 1 by 9 minus 2 4 1 2 minus 2 4 4 1 minus 2. Next we move on to the next problem. Here the given matrix A is equal to 0 1 2 1 2 3 3 1 3. Here the order of the matrix is 3. Let us consider A is equal to I3 of A. Then write down the matrix A. Here write down I3 is the identity matrix. The diagonal elements is unity. Then interchange on both the side, interchange row operation, apply row operation R1 to R2. Then after applying the operation, in the next step we have to again row operation R3 dash is R3 minus 3R1. Apply this. Then we move on to next step. R3 dash is R3 plus 5R2. Operation, after applying this operation, we get this matrix. Then we have to go for R1 dash is R1 minus 2R2. Then R2 dash is 2R2 minus R3. We have to go do the operations successively by making the diagonal elements must be unity. Then we get the identity matrix. Identity matrix is equal to matrix B into A. Then take the inverse. Then it's A inverse is equal to B. Then we finally we get the inverse of the matrix. Thank you.